Lesson 11.5. So we're going to continue to look at circumference, area, and volume as this chapter says. Now we're going to focus on volumes of prisms and cylinders. So this first little blurb, like we've seen in this pattern thus far this chapter, is that they kind of explain where the formulas come from. So the idea of the volume of a prism, which maybe you already know, the formula is the area of the base times the height. Now what you're probably more familiar with if we think about it is if I give you like something like this, we say, what's the area of a prism in general? And you would say length times width times height if it's a rectangular prism, right? The volume is length times width times height. Well, what is length times width? Isn't that just the area of the base? So this is really the area of my base times the height of the prism. So that's where they get the formula capital B times H. Capital B stands for the area of the base and H is our height. Now the way that theorem works is if you think about it, think about a cross section like we did in the last lesson. So that's the area of the base. So it's the same as the base. And now if you almost consider like a ream of paper, every one of those pieces of paper have a certain, like if they span all the way up the height, that's how we do the area of the base. And then for every like paper, if you were to think of a ream of paper, like I said, which would represent the height. Now the cool thing with this is that there's this principle, Cavalieri's principle, where if you were to take a ream of paper and just kind of push it and all of it would stay intact but slanted, as you see in this second image, it would still have the same volume. It still has the same number of pieces of paper. They're all the same. It's just oriented a little differently, right? So the cool thing is that when we find volume of a prism, even if we have a slanted one, as we see here, we still find the height of the actual prism, not that slant height. That's not what we look at. We look at the height of the actual prism, and that will somehow be given to you. Okay, so let's try a couple volumes. Now, the ones up above were easy. They were rectangular prisms. These ones are a little more involved, but still very doable. First one, we have a triangular base. So whenever I think of the formula, volume equals area of the base times the height, I first need to find the area of my base. So in this case, this is my base here, okay? It's 3. Notice that right angle down there, that's pretty critical. So if I redraw that triangle, this is 3 by 4. We could fill in that this is 5, but that's not really critical at the moment. And I want to find the area of this. So area is of a triangle, 1/2 little base times height. So these variables mean something, capital B, little b. But anyways, 1/2 3 times 4, half of 12 is 6. Okay, so that's my area of the base. So instead of putting a capital A here, I could put a capital B because it's the area of my base. So that's going to substitute, sorry. Oh my goodness. Okay, we're just not going to put a B here. B here, okay? All right, so formula for volume, let's use a different letter. Volume equals capital B times H. Capital B we found is 6. Height of the prism is 2. So my total volume is 12 centimeters cubed because we're talking about volume here, okay? All right, in this next one we're doing area, our base is a trapezoid, so area of a trapezoid. All right, so area of a trapezoid, which we can do capital A. I'm gonna, even if you wanted to do a capital A with a little subscript of capital B, however you choose, or just remember it's the area of the base, it doesn't matter. But 1/2 base 1, plus base 2 times the height. All right, so let's go ahead and carry that down here. So I'm talking about this trapezoidal region right here. I see that this is 6, so that's also 6 centimeters. And if I just redraw this so that I'm not looking at it kind of upside down, I have 6 here. I have the entire bottom, which is 14. And I have this little distance here as 3. Okay, and they show me that with a right angle. So the area of this trapezoid is going to be 1/2 times 6 plus 14 times 3. Now 6 plus 14 is 20. Half of 20 is 10. 10 times 3 is 30. So the area of my base is 30. So now I just go ahead, and this is kind of the easy part. I take that and I say volume is equal to area of the base times the height. So the area of the base, this here, which we know it's the base because it's parallel to another polygon of the same, another congruent polygon, is going to be 30, and then the height of the prism is 5. And that's how I get 150 centimeters cubed. Okay? All right, let's go on to the next one. Okay, so here, this same principle, they just kind of spell out how it works and relates to cylinders. So we're just gonna, essentially it's the same thing, but they kind of explain that with some visuals, which are really nice. But we're just gonna continue moving on. They say that same formula applies when we have a solid here with it's a cylinder. It's the area of the base times the height. Now in this case, the area of a base, if we're talking about a cylinder, it's always the same. It's always a circle. If we're dealing with a cylinder, my base is always circular. So area of a circle is pi r squared and then times height. So they've just taken this formula we already knew and kind of made it specific to formula for area of a cylinder because our base is always a circle. So here they want us to find the volume of each cylinder. Now they don't tell us whether to leave our answer in terms of pi or to round it. So what I'm going to do is I'm going to do both. I'm going to leave my answer in terms of pi and show you what that would look like, and then the last step is we'll just multiply it to figure out rounded what it would be more likely to be. Okay, so we have a circle here. I'm gonna we can just do volume equals pi r squared h. My radius is 9 and my height is 6. Okay, so pi times 81 times 6. So if I were to leave my answer in terms of pi, I would just get 486 pi. And I could leave my answer like that if I wanted to. Now, obviously that doesn't really tell us too much, so it's helpful to also turn that into what it would look like if I go ahead and multiply that by pi. So I'm going to multiply it, I'm just going to use the pi button. You could also use 3.14, and I get this number here, and I'll round it to 2 decimal places. So 526.81, and don't forget to label, again, feet cubed. Okay? Either answer is accurate, just depends on what the directions are asking or what the situation calls for. All right, in letter B, we can go ahead and apply that Cavalieri's principle where it says, even though it's slanted, since they're giving us the height, we use the exact same formula, which is pretty nice. Okay, so I'm going to go ahead, volume equals pi r squared h, which in this case, pi, my radius is 4 squared times the height 7. 4 squared is 16. 16 times 7 is going to give me 112. So I have 112 pi centimeters cubed. Or I can rewrite that as 351.86 or 86 hundredths centimeters cubed. Either one works, okay? All right, I feel like you're probably doing a pretty good job with these, as it's just a lot of substitution and calculating based on that. So let's just practice 2 more to make sure there's no questions, especially when this principle comes into play. All right, so here we have the area of the base. It's not a cylinder, so I have to go back to that generic one. Then my base here, which I'll work out on the side, is a triangle. Okay, so they give me, it's a right triangle. This is 5. My height is 9. Now it's important that they tell us it's a right triangle because that allows me to know that one is my base, one is my height. If they don't, then I don't really know. Then I would maybe need to find something. So it leaves open a lot more options. So the right angle symbol there is pretty critical. All right, so the area of my base, and I've been writing it like that, is 1/2 of 5 times 9. 5 times 9 is 45, so half of that is going to give us 22.5. All right, so now let's substitute that in for capital B. So I'm going to have 22.5 times the height of the entire triangular prism, which is 8. And when I multiply those together, I get 180 meters cubed. There's the answer for number 1. All right, number 2, we have a cylinder, so it's just going to be the formula of pi r squared h. Pi, the radius is 8 squared, and my height is 14. Okay, so if I calculate 8 squared, that's 64. 64 times 14 gives me 896 pi, and that's the first answer left in terms of pi. The second answer is if I multiply that by pi, I get 2,814.87 cubic feet. Okay? Alrighty, so that is that. We're going to move on and take a look at some density now, but I'm going to stop this video and leave that for the next one. Okay? Thanks, guys. See you in just a bit.